logging back in with another video. It's a log joke. This is by popular request because I really would have been doing something else with my night otherwise. I'm just kidding. You know, I'd just be sitting around doing math. So anyways, how do I solve the kinds of questions that we're asking this? Well, if imagine I had this log 80. If I type that in on my calculator, I'm not going to get anything really helpful out of it. And that's because, well, log is in base 10 here, and 80 is not a power of 10. So I'm going to get some sort of weird exponent is the only way to get 10 to the power of something, giving 80. So yeah, that kind of sucks. Well, this is on purpose. They're asking you this question because they're going to give you a little bit of extra context. They're going to say, hey, if you can tell me what log 2 is and log 5 are, or if you can break this down like that, then I will say, okay, well, log 2 is x. I'm pretty sure it was x, and this one was y. Now, you can tell me what this number is in terms of x and y. Spicy, or at least less impossible. I don't know, whatever you think. This is a typical kind of question to make you think as logarithm law as possible, as opposed to just, well, I have a log button on my calculator. And so it's important that we understand how to do this kind of question. We talked about this in class, but I'm putting it on video now, and I'm going to include an extra bonus question because that's what I do with my life. And hopefully this video helps if you need to just see it watched through a couple of times. So I picked an easy one, quote unquote, and a hard one. No need for quotes here. We're going to do both, and we're going to talk about a general format here. I'm going to show how I would break this down, but I'll add this caveat right now. The very first thing I want to do with all these is I want to think about the factors of our arguments. Now, remember, our argument is the term upon which the log is being applied. And so my argument, in this case, 80, whatever I'm doing, I want to factor it. And so I'm going to factor it however I think is easiest. What you want to do is you want to get it factored into recognizable bits. And there should be, for this kind of question, in our case, 3 bits or ideas that are recognizable. Obviously, log 2. If I can get log 2, I know it's x. So I want to look for 2's. Log 5 is y. So I want to look for 5's. And then, well, our logarithm, it's not saying what base it is. So it's kind of the basic base, which is 10. So I want to look for 10's. So when I think about breaking down our first one here, 80, the very first thing that jumps to my eyes is that it's a multiple of 10. Look, there's a 0. Obviously, it's a multiple of 10. So I can say, well, this is like 8 times 10. So I can say, well, this is log 8 times 10. And hey, 8, I know 8, it's a power of 2. So I can say this is like log of 2 cubed times 10. So if you don't believe me, type 2 cubed times 10, you'll see it's still 80, right? So I'm not changing anything. Now here's the next idea. Well, great, I haven't changed anything, but I have a product in a logarithm. If my argument is a product, I can instead break that argument into separate logarithms. So I can say this instead as this, log 2 cubed plus log 10. And that's pretty spicy. So in fact, I quite like doing that. Now, with this, I can now do a little bit of solving because, well, log 10, that's log base 10 of 10, right? It's our kind of basic log. That's just 1. Easy peasy squeezy lemons. Over here, I've got log 2 to the power of 3. Well, our 3 is going to just act as a coefficient because of our power of a log rule, or I guess log of a power. Either way, our rule here says I can just bring this coefficient in front. Log 2 is x. 3 times log 2 would be 3 times x. So I get this, 3x plus 1. Now, hold on, Mr. Herman. I went through, and that's not what I found, and I know I did it right because I'm smart. And what I got was 4x plus y. And I'll tell you that, yes, that's possible because you could have said, well, log 10, that's log 2 plus log 5, because 10 is 2 times 5. And you'd be right. And so great, write your 4x plus y. See if I care. I like 3x plus 1. Both of them are right. And that should just kind of show some of the flexibility we've got here. Our next one, a little less flexibility, but a lot more going on. Does that make up for it? I don't know. Maybe you don't like this. I'm going to start this one a little differently. I'm going to start by breaking it into parts. Then I'm going to analyze each part to sort of decide what I want to do with it. Obviously, I've got a quotient in here. So sort of the first intuitive step is, why not I break it down using our log quotient law? So I'm going to have log of my numerator, which is the quartic root of 32. And then I subtract my denominator. And I'm actually going to break my denominator up by my power, or rather log product law. So this is log 125 plus log of root 1000. Now, keep in mind, this has to be in brackets because they're both going to end up being subtractions because they're both in our denominator. So need this subtraction to be outside of brackets so it distributes onto both our terms. Okay, let's attack one thing at a time. So if I'm dealing with this quartic root of 32, well, I'm looking for 2s, 5s, and 10s. I know this isn't a 10. I know this isn't a 5. I know it's got to be 2s. And if I think back, well, you might remember 32 is the 5th power of 2. Yeah. You also might think of it as, well, it's got to be a 2. It can't be a 10 or a 5. So I'm just going to try different powers of 2 until I get there. And so you find this. 4 and oops, our 4 stays there and our 2 is to the power of 5. Now you could turn this into a mixed radical, but I don't think that's going to help you. What I think you'll find a lot easier is try and turn this into just an exponent, not a radical with an exponent, but all in one exponent. Remember, if I've got a quartic root, that's like saying 2 to the power of 5 to the power of 1/4. And now by my power of a power law, this just, we multiply 5 times 1/4 and that's 5/4. Cool. So all this together gives me then log 2 to the power of 5/4. Nice. Personally, I think this 125 is pretty elementary, right? I know I'm looking for 5s. It's obviously got a 5. And it doesn't take me long to find out this is 5 cubed. So let's go ahead and let's write that out. So minus log 5 cubed. This one, I'm going to have to do the same sort of thing I did with the 2s by saying, well, there's no perfect root of 1000, but I know 1000 is a power of 10. So why not I say this is 10 to the power of 3 and the square root of that. Sort of our implicit 2 here, right? It's there still, so that I know I can write it as a nice little exponent of 3/2. So let's go ahead and let's chuck that in here. It says plus log 10 to the power of 3/2. And now let's do a lot of our power of a log law, or log of a power law. We're going to bring this in as an exponent, or rather our exponent we're going to bring in as a coefficient. So it's 5/4 log 2 minus, this will be 3 log 5 plus 3/2 log 10. Log 2, we already know from above, that's x. So this is 5/4 x. And that's going to be subtract 3, well, this is y, so 3y. And log 10 is just 1, so plus 3/2. I could turn this into an equivalent fraction statement and put it all together, but that seems like a waste of my time. So I'm just going to leave it like this. And if you check the answer key, you'll find out this is the right answer. The steps of logic that I'm using, it's important to know I'm just thinking about factors. I'm breaking things down to the factors. I know what I'm looking for. And really, could I do this without knowing all the factors of 2s and 5s and 10s? Yes, but it'd be hard. So what do you think something that's kind of a valuable thing to work on being more and more comfortable with? What are powers and cubes of numbers that are commonly used? Like 2s, 3s, 5s, 6 is a little bit, 10s especially. All these are kind of important details that are going to keep recurring and can keep coming up. So make sure you're remembering them.